Hello and welcome to example 7.2.3. Suppose that x has density function f sub x of x is 2 over x cubed for x greater than 1 and 0 otherwise. If t is 1 over x, we are asked to find the density function of t and asked to give the support of t, which really we should do anyway while giving the density function. T is 1 over x, so t is a transformation. It is a function of this random variable x. But this function 1 over x, if we sketch it, we will see that it is 1 to 1, so it is invertible. Let's just graph it here in the positive quadrant. So this is the t-axis and the x-axis. If x is greater than 1, we are here. And so we are looking at this part of the function. This is not an increasing function. It is 1 to 1, but it is not increasing. It is decreasing. So we have to be careful when we deal with the inequalities that are going to arise. In particular, the formula that we saw in a previous video about the density functions of transformed random variables does not apply because that was an increasing function that was used in that formula. However, the method of the proof, if we're careful about manipulating the inequalities, the method of the proof will still lead us to a correct answer. So right here, what is the support of t? Well, we can see immediately on the graph that if x is greater than 1, then t, well, if we plug this in, that's a t value of not 0, of 1. And so we can see that the t values are going to be between 0 and 1. So 0 excluded to 1 excluded. So we can give an answer to this part right away. The support of t is going to be between 0 and 1. So let's introduce some notation. Let's let capital F sub t of t be the CDF of t, and small f sub t be the PDF of t. And so as we've done in previous videos, we're going to write the definition, the probability that t takes values that are less than or equal to little t. That's the definition of the cumulative distribution function. So this we can replace by 1 over x is less than or equal to t, and this is where we need to be careful. We can't just flip the inequality. We need to make careful work of rearranging this. And so if we multiply across, as long as x is greater than 0, which it is, right? If x is greater than 1, then certainly x is greater than 0. We can multiply up, and we're going to get 1 is less than or equal to x times t. And as long as our t values are positive, well, they are, that support is there, we can divide. So this is the probability that 1 over t is less than or equal to x. Now, that's not what we're looking for in terms of the CDF, right? The CDF has the random variable on the right. So what do we, that's the left, on the left of the inequality is less than. And so what we can do is rearrange this 1 minus the probability that x is less than 1 over t. We can use the complement rule. Now this is nice because this gives us the exact formulation not for the CDF of t, but of x. So we can say that this is 1 minus the CDF function f sub x of 1 over t. And so I guess I should introduce that as well. F sub x, since that's not already part of the problem, let f sub x of x be the CDF of x. Now here, you might say, well, there's no equal sign, so how come this is the CDF? Well, for a continuous random variable, being equal to or not, remember, is not important because the probability at a single point gives 0. So we can just as well take this to be the CDF regardless of whether we have the equal sign or don't. Now, we want the density, and so we're going to use the relationship that the density function is the derivative of the cumulative distribution function, which means that we want the derivative of the function that we have here. So 1 minus f sub x. You'll notice we don't have a rule for f sub x, but that's okay because we are not going to need it. If we take the derivative, well, the constant goes away. We're going to have minus f sub x prime of 1 over t. Now this is good because this gives us the density of x. So minus f sub x, little x, not prime anymore, that is the derivative, of 1 over t, chain rule, times 1 over t prime. Now this rule we do have. That is the rule that is given to us at the top here, the density for x. And so this is minus, and we plug this in. I've already forgotten what it is. 2 over x cubed. So 2 over 1 minus t cubed times, and the derivative here is going to be minus 1 over t squared. So the minuses are going to cancel each other out. That's nice. We're going to get 2t cubed over t squared, or just 2t. Now this is not a complete answer, right? That has to be given in terms of the values of t where it is applicable. In other words, the support of t. Well, conveniently we figured out the support already, and so we can give the complete answer that the density function f sub t of t is 2t for values of t between 0 and 1, open interval, and 0 otherwise.